Alright, today we're going to take a look at section 6-4. This is covering elimination using multiplication. So we were just talking about elimination in the last lesson, and this time we're going to add in multiplication instead of just addition and subtraction. So same process, one step more difficult is all. So the key ideas here, when you're using elimination, the whole idea is that you're trying to delete one of the variables so that you're only trying to get one of them on a side by itself. So this says step 1, it says multiply at least one of the equations by a constant to get two equations that contain opposite terms. Remember in the last section we would end up with like positive 2y and negative 2y and they'd cancel, or positive 3 and negative 3 or something. So the same goes for this section, but you might have to do some multiplication to get them to be exact opposites. So this says add the equations together, eliminating one of them, and then solve the equation. I suppose you could use subtraction here too, it doesn't have to just be addition. And then it says substitute the value from step 2 into one of the equations and solve for the other variable. And then write as an ordered pair. So all of step 3 is just like the last lesson. Let's take a look at an example. Move me down here for a minute. So example 1 says 2x plus y equals 23, and we have 3x plus 2y equals 37. I'm seeing that neither one of these has exact opposites. You can't really add or subtract these yet. However, their suggestion is multiply the first equation by negative 2 so that the coefficients of the y terms would be additive inverses. So if you do that, take the whole darn thing by negative 2. Let's see what that would look like here. So they're taking this whole thing and they're going to say by negative 2. So negative 2 times 2 gives us negative 4x. Negative 2 times 1y gives us negative 2y. And I saw that this said plus. Now it says a minus because you multiplied by a negative number. So it changed the addition to a subtraction problem. And then negative 2 times 23 gives negative 46. The other problem, the other equation, was written exactly as it was printed. And now we can add these. When you add them, these cancel out to nothing. So there's a big 0 here. If you want, you can write in the 0. You don't have to. Negative 4x plus 3 gives negative x here, negative 1x. And then we had this result over here was negative 9. So that tells us negative x equals negative 9. If you divide by a negative 1, dividing by negative 1 gives us a positive 9. Once you have this positive 9, you can plug this back into either one of your equations, or this one if you want. Plug it back in and solve for y. So that's what they did next. So they plugged this back in for this first equation, plugged in the 9, and you end up with y equals 5. So 9 and 5, this is your solution. It should always be written in parentheses with a comma there as well. So this is an ordered pair, otherwise it's just two random numbers sitting next to each other, but make sure it's parentheses 9, comma 5, end parentheses. Okay, you try. Test this one out, see what you can do, hit play when you're ready to see my solution for this. I'm going to go ahead and talk through it, so let's see what I did here. So I took this first equation. There are all kinds of ways to do this, so if you end up with the same answer but you did it a different way, you go for it. You do you. I chose to take this top equation and I multiplied by 3 for this whole first equation, so that's 3 times x, 3 times 7, and 3 times 12. So for each of those I ended up with 3x. Oh, this should have been, hold on, I messed up here, 1 second. Okay, I fixed it. So I did a common mistake and I did not take the 3 times each term here, and I should have. So now that I fixed it, it should say 3x, 3 times 7 is 21y, 3 times 12 is 36. So once I did that whole thing, now I'm going to copy the second equation right underneath it. And then I see that mine, I can't take 3 plus 3 because I'd end up with 6, but I could do a subtraction. So I threw a subtraction way out in front, and I'm going to do 3 minus 3 instead of adding them together. 3 minus 3 is 0. So 21y minus negative 5y would mean 21 plus positive, right? Two negatives make a positive. So 21 plus positive 5 would give 26y. And then 36 minus 10 makes 26. Then I got y on a side by itself. I got 1. Then I could plug this back into my favorite equation, and my favorite one is the top one because it does not have a negative in it. I like to avoid negatives if at all possible. So I'm going to put the 1 in this first equation, and I end up with x equals 5. So therefore my answer, 5, 1. X always is listed first. All right, let's look at another example here. So this one, this says use elimination to solve the system of equations. Again, neither one of these have the same variable, or coefficient, sorry. I'm seeing a 4, a 3, a 3, and a 5, and all that's looking messy. So what they did is they took the first equation times 3, multiplied by 3. The second equation they multiplied by negative 4, and then they ended up with additive inverses here, positive 12 and a negative 12. Then they did the adding them together. 12 plus negative 12 gives 0. 9 plus 20, 24 plus 92. I get y on the side by itself, and they got y equals 4. Next, once they figured out y equals 4, they came back over here and said, okay, well, if y is 4, what's x? So they plugged in the 4 in for y in their favorite equation, which was the first one, and blah, 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 do math, ask if you've got questions, feel free to ask, and I'll work through any of these. They ended up with x equals negative 1, so this is their solution. So, what's next? Method 2. So another option, what did they do? Oh, they chose to get the other variable. So you're saying, well, how would you know? What if you didn't want to do the first equation times 3 and the second equation times 4 to get these to be 12s? What if you did it a different way? And what if you got the second variables to be common, which might be like 15, because 5 times 3 is 15. Go for it. The nice thing about this is there are lots of ways to solve these problems. As long as you get to the right answer, then it's likely a method that works. So ask if you've got questions, but know that there are multiple ways to do this. So don't rely on copying it down from my examples or doing it exactly like a classmate. You do you. As long as your process works, it's good to go. You're fine. So you can look through all of this work just to check it in case you want to do the other method, but either way works. Okay, now you try. See what you can do. Hit play when you want to see my solution. When I worked through it, I chose to take the top equation times 2, so that would give me a 6x, and the second equation I multiplied by 3, so that also gave me a 6x. However, I know that when I did that, these do not add together to cancel out, so again I'm going to subtract. I'm going to say 6 minus 6, and then 4 minus 15, and then 20 minus 9. And when I did that, I ended up with y equals negative 1. Once I did that, once I did that, then I could plug in y equals negative 1 into, I chose the second equation, and I ended up with x equals 4. So let me know if you've got questions on that. Alright, let's look at a word problem. Lots of info. Fishing boat travels 10 miles downstream in 30 minutes. Return trip, which would also be 10 miles, right? 10 miles coming back took 40 minutes. We need to find the rate, or find the speed in miles per hour. Oh, it says find the rate in miles per hour of the boat in still water, because obviously if it took more time coming back, they must have been going upstream against a current, so that means the current was probably helping them along the way there, and then slowing them down on the way back. So they're choosing to say B is the rate of the boat in still water, C represents the rate of the current. So they're saying rate times time gives us distance. So rate times time gives us distance. So we could write this out in equation form. Since the rate is miles per hour, they're saying here rate is, now since it's miles per hour, we don't want to put like 30 because that'd be like 30 hours, right? So 30 minutes could be represented as half an hour. 40 minutes would be represented as 2/3 of an hour. So they're choosing, I know there's a lot of info here, so stay with me here. So they've got rate of the boat plus the rate of the current on the way there. Remember, that was helping them, so the speed of the boat plus the speed of the current would be the total rate. Half an hour, 10 miles, so stick that all together. We've got 1/2 times b plus 1/2 times c equals the distance. They did this because of this. 1/2 times, rate times time. Rate times time. So you could write this in parentheses. 1/2, you could do this times time, but they did the distribution process. So 1/2 times b plus 1/2 times c equals 10. Same thing for the other direction, but this time the current is headed the other direction. It's hurting them. So they're saying the rate of the boat minus the current would be the overall speed. So once they did that, it looks like they're multiplying each of these by 2/3 to get to their final equation. If you multiply by 2/3, you end up with 2/6 for both. 2/3 for the first equation, 1/2 for the second equation, and you end up with 2/6 each, or I guess you could say 1/3. Same process. It looks messy because there's fractions. These cancel each other out. I'm seeing that there's a positive and a negative, so these cancel, these get added together. And then from there we simplify, we keep going, b equals 17.5. So that means the rate of the boat in still water is 17.5 miles per hour. Okay, if you want to plug it back in, you could find the rate of the current, but they're not asking you to do that. Okay, feel free to scroll back and take a look at that. When you're ready to move on, take a look at this one. So this is talking about a helicopter, 360 miles with the wind in 3 hours, but the return trip, again 360 miles, it takes 4 hours, so in a whole one more hour for the way back. So see if you can set up your equations and hit play, pause right here and work through it, and then hit play when you're ready to see my work for it. When I did this, I set this up like I did the last problem, like the book did. So I went back to the previous screens to see that boat problem, and I set up a table just the way they did it. So I did rate was helicopter plus wind for the way there, and it took 3 hours, and this was the distance. So rate times time equals distance would mean 3 times h plus 3 times w, 3h plus 3w, equals 360. And then on the way back, it would be the helicopter minus the wind, since the wind would be hurting him, and it would be making the speed slower, times 4. So 4 times h minus 4 times w here, and 360 there. So next thing I'm going to do here is I want to put these together, but I see that neither coefficient, the coefficient for either the x or the y, nothing matches. So I'm going to take this first equation times 4, and I wrote that in orange here. The second equation, I multiplied it by 3, and I wrote it here. When I'm adding these together, I'm going to cancel these two out. Do you see that? These cancel. And I end up with 24 hours, 24h equals this, 2,520. So h equals 105. When I plug that in, okay, so this is the answer. H is 105, so it's 105 miles per hour. If you wanted to find the speed of the wind, you could plug that back in for h, solve for w, and I got 15. So I could solve for the speed of the wind there. Okay. Feel free to pause right here, take a look at my work, and let me know if you have questions. When you're ready, start the homework. So there are 9 problems here. Let me know if you have questions.